All of you switch on the camera first. Let me see who are present. My voice is not proper, so you have to accept it. Somebody is absent, so who is absent? Let me see. Okay. Sahil is there. MTech students, okay, they are also there. Okay, fine. So we can start. Okay, fine. So you can take out your camera. Attendance is over. Only one candidate is absent. Let me directly go to the PPT. Now, see this top figure is that picture you have already seen. That is the El Centro ground acceleration along north-south. So there would be east-west component also, and there will be vertical component also. So for this north-south component, numerical integration was carried out. Now, numerical integration was carried out for different parameters. So just look at the graph. Let me expand it. So numerical integration was carried out for different parameters, which gave us these graphs. Let me repeat again. For El Centro earthquake, numerical simulation or numerical integration was carried out, which gave us these graphs. Look at the graph carefully. Look at the graph carefully. And any sentence, any comment that you can make? Look at all the graphs carefully. And then you can make 2-3 conclusions. What are those conclusions? These are not earthquake recording. These are after the numerical integration has been done by Duhamel formula. So when the numerical integration was done with Duhamel formula, we got these graphs for different parameters. Don't get confused. Tn means natural time period. So 2 pi by Tn will be natural frequency in radian per second. and 1 by Tn will be natural frequency in hertz. Let me repeat again. Sometimes we use omega n, but in America, the people generally use Tn. Tn is natural time period. 1 by Tn gives us frequency in hertz. 2 pi by Tn gives us frequency in radian per second. So Tn indirectly represents natural frequency because natural frequency can be calculated from time period. They are connected to each other. I don't know why in America people like this Tn rather than omega n. But okay, the simulation has been done for by varying two parameters. Not one is time period, natural time period we have varied, and we have also varied damping, and we got different graphs as the graphs are before your eyes. Any conclusion, any comment?
So more the natural frequency and damping, the less the acceleration will get.
There is nothing like acceleration in the graph.
So sorry, sir, displacement.
Actually, our conclusion should be one parameter at a time. But let me tell you, damping increases, what happens? Peak, a circle क्या बता रहा? This circle is actually representing peak value. But as damping increases, the peak value decreases. As damping increases, the peak value decreases. And this we cannot say conclusively because only two pictures have been taken, 0.5 second, 1 second, 2 second. But we can say that in lower frequency zone, peak value will be higher. In lower frequency zone, peak value will be higher. So these graphs, these observations, keeping the damping constant first, a simulation was done for many natural frequencies or many time periods, and then we got this graph. The graph was shown last class. We got this graph. Of course, along x-axis it was 1 by Tn, or CPS matlab cycles per second, which is 1 by Tn. And so this is the values, peak values. Now, but this peak value was for zero damping. The simulation was done for zero damping. Now, because with damping, the amplitude will be lower and lower. We presume that, so what is the red line? Red line is called design spectrum. So design spectrum is different from response spectrum. Black line is response spectrum, actual values obtained from numerical simulation. Now, we cover the response spectrum by a graph who is greater than the response spectrum values. and we call it design spectrum. Now, one can possibly ask me why design spectrum should be different from response spectrum. There is a reason. Response spectrum is calculated assuming that wherever the earthquake has been measured, earthquake remains same in the whole area. It may not be. It may not be. Earthquake has been measured at one location, but maybe 5 kilometers here and there, it may be slightly different. That is one thing. Second, when I apply the spectrum for a building, effect of earthquake on the building will also depend on what is called soil structure interaction, means what kind of soil is there. Now, this black line presumes that the earthquake as it is goes to the foundation of the building. But suppose there is loose soil, then the effect of earthquake will be different. So, depending on the soil condition, depending on the location, actual effect of earthquake will be slightly different from what numerical integration has given us. So what do? We cover the graph with another regular graph which is greater than this, and we call it design spectrum. एक मिनट देखो, फिर you can ask me a question. समझने का कोशिश करो, what is the difference between design spectrum and response spectrum? ठीक से देखो. Actually, the civil engineer, he doesn't know response spectrum. He is given the design spectrum. So what does he do? We will explain little later. He calculates. हाँ बोलो बोलो.
सर आपने स्टार्टिंग लेक्चर्स में एक वीडियो दिखाया था रिगार्डिंग अर्थक्वेक एंड उसमें
नेपाल में हाँ.
यस सर, एंड उसमें जो स्टैचू था उसके पूरा साइड का पार्ट
गिर गया
and the only statue part is remain constant. So actually I unable to recall this or दोनों को correlation नहीं कर पा रहा हूँ ये तो
this is the correct PPT that you can correlate. Natural frequency of that building statue was put within a civil construction. Agree? 4 कॉलम थे, उसके 4 कॉलम थे, ऊपर में उसका एक छत था.
Yes sir.
So that civil construction will have some value of natural frequency.
Yes sir.
Statue will have another value because statue was not at all placed on the building.
Yes sir. Yes sir.
So if the natural frequency of the statue is somewhere here and natural frequency of the building is somewhere here,
yes,
who
sir.
will fail?
The building part.
Building. So, I mean, I will basically that is exactly today you will see that interesting thing.
Yes, sir.
Earthquake doesn't damage everybody in the same manner.
Yes,
Even
sir,
if
yes,
they are. So, I mean, you don't try to think कि वो छत गिर गया, स्टैचू अनएफेक्टेड रहा, नॉट बिकॉज अर्थक्वेक वाज डिफरेंट फॉर देम, क्योंकि दोनों एक ही जगह में है, अर्थक्वेक एग्जैक्टली सेम है,
Yes, sir.
Earthquake wasn't different for the statue or different for the building. But building fell down, statue did not, क्योंकि उनके natural frequency अलग अलग थे. Earthquake से था.
Sir, so is there any specific criteria while designing any material or any product that if we kept this in particular manner, then it will be less affected by earthquake or
There are not one criteria, series of criteria are there.
yes, sir.
No, let me finish. Many criteria are there. That is why there is a complete subject called earthquake resistant design, a full semester. It takes full semester to understand that subject because there are many criteria. I will not discuss all the criteria, but I will give you some idea. At least one or two criteria I will give you. I think in the last class, we have already suggested that if the natural frequency can be kept greater than 30 hertz or 33 hertz, it will be absolutely safe. I think in the last class I have mentioned it. On what basis I am saying that? Because you can see that, I mean, this is only for El Centro. Today we don't design it for El Centro. Remember that. So let me finish first how design spectrum is made. To make the design spectrum, we collect earthquake data in the vicinity. See, if I want to design a 40-story building in Nagpur, I will not look at El Centro because El Centro is far away. So we will collect earthquake acceleration data from places close to Nagpur. Now, this is a big problem. Earthquake is not measured everywhere. Unfortunately, earthquake is measured only at few places. India has started making seismic recording station recently, only recently, last 20-30 years, India has given importance to it. So then whatever earthquake data we get, we carry on the simulation, and then there are experts who finally prepare this upper limit. It's not that easy. It takes 10 to 20 years to prepare this design spectrum. Design spectrum will be different from one place to another place. Design spectrum will also be different for damping. But one common sense is there. As damping increases, design spectrum comes down. That means the damage that can happen, it reduces if damping is more. It is established throughout the world. It is not guess. It is established that as damping increases, damage any earthquake can create will reduce. Second thing, throughout the world, people have seen that from place to place, some earthquake will die out at 18 hertz, like this happened in El Centro. Some other earthquake will die out at 30 hertz. But last 100 years, people have seen a very common thing. Earthquake doesn't have more than 33 hertz component. So two criteria comes out from this. One is, if possible, design your civil construction natural frequency higher than 33 hertz. Now this is a funny conclusion. Why it is funny, I will explain. I mean, this is theoretically perfectly okay, practically संभव नहीं है. But second conclusion practically संभव है, increased damping. So wherever earthquake can create havoc, we have to introduce additional damping. Now please remember, steel structure, they have inherent damping of 1% or 2%. Concrete structure, they have little more damping, 5% to 10%. But that is maximum. But even 10% damping may not be enough. So those in California structure, we add damping. And whatever I have said, you just write down, then I will ask a question regarding Nagpur. But you write down whatever I have said. I have just now said two criteria. If possible, keep the natural frequency greater than 33 hertz. Second, put damping as much as possible. इसको लिखो, फिर हम पूछेंगे एक चीज. Our first MTech first semester students, they have not been to Nagpur, but undergraduate students, they were in Nagpur. So I will ask all of them, have you seen the flyover bridge in Bardi, Nagpur? Undergraduate student. Don't tell me that. Shraddha, what for you have been there?
Sir, we have gone to buy the workshop course.
Okay, ठीक है. Can you recollect? I mean, whatever I am saying, that is not only true for Nagpur Bardi flyover, it is true for any flyover anywhere in India. If you look at the metro flyover, even in Hyderabad or Mumbai, anywhere, you will see flyovers are horizontal construction supported on vertical pier or vertical columns. Do you agree? A
Yes, sir.
vertical column, is it directly cemented to the horizontal flyover or there is a gap? Have you seen?
Sir, there is a little gap.
You.
Maybe because of damping factor.
No. Isn't it? There cannot be a gap because the flyover cannot remain floating.
No,
That
sir,
gap
no,
was
sir.
filled up. That gap
That
was
is-
filled up by
that-
something.
Yes, sir. Yes, sir.
So
Is
next
why
time,
from the
next time you must look at it seriously. We have friction liners. Friction liners. So that there are two reasons why the gap is there. There are two reasons. One is the horizontal part of the flyover, it expands due to temperature change. So if we cement it, then its expansion will be restricted. So we keep liner so that the horizontal part can slide forward or slide backward. The column will not object to it. So there are liners. Second advantage is that during vibration, if it occurs, these liners will provide damping, and that damping is Coulomb damping, friction damping. So in case earthquake occurs, generally the vibration in any flyover is very, very small because of vehicle movement. There is almost zero. But if earthquake occurs, then the vibration will be much large, maybe 2-3 inches. 2-3 inches. So in that case, these liners will provide the damping. So, two major concepts are used. One of them not practically possible. Which one is not practically possible? Keep the natural frequency greater than 33 hertz. Civil structure invariably will have natural frequency between 2 to 5 hertz. Unfortunately, any civil structure. I mean, conventional civil structure. Second is damping. But people have done research, and Srabha was asking me, if earthquake occurs and you have a building, it's not necessary that every building will get damaged by earthquake. Number one, why every building will not get damaged by earthquake? Number one, the natural frequency of the building may not be within 30 hertz, but this is generally a remote possibility. In today's context, city context, if you go to village, almost all the building will have natural frequency greater than 30 hertz. क्यों? उसके कंस्ट्रक्शन ही अलग होते हैं. The construction of the village houses, that is solid wall and not column construction. Column construction में problem क्या है? Advantage क्या है? That material, cement कम लगते, but it becomes cheap, but its natural frequency decreases. So for earthquake, column constructed house is more susceptible to damage than our typical village houses. So why all buildings are not get damaged in the same manner? One is natural frequency. Second is, of course, damping. But the third point is most important. Even if natural frequencies, you tell me, looking at the response spectrum, perhaps this natural frequency is most dangerous. Agree? And how much it comes out to be? Maybe around 0.32 hertz. So suppose a building exists near El Centro whose natural frequency is 0.32 hertz. And if suppose this earthquake repeats, do you think that the building will definitely go into resonance and collapse?
Yes.
किसने बोला यस? नितेश कुमार एमटेक. ओके, बीटेक के बच्चे लोग. Suppose El Centro earthquake repeats itself tomorrow, and in El Centro there is a building having कितना natural frequency मैं भूल गया नीचे में, या 0.32 hertz, where this peak value occurs. So what will be your guess? कि building will go into resonance and it will collapse? I mean, will you agree if I say this? Nitesh saying yes, लेकिन बाकी लोग क्या कर रहा? See, you have to change yourself. Again and again I am saying, with this attitude, you cannot be a good engineer in life. You have to try speaking out. And you have to try thinking. इतने डरे हुए रहोगे तो मुश्किल है.
Sir, it will go in resonance.
So most of the students I know, they will say resonance will happen, but that is wrong. Why resonance will not happen? I mean, resonance will happen, but building may not fail. Why? Say damping is 0. One reason.
Sir, since that particular displacement, like that particular maximum displacement happens for such a small time that it doesn't get time
That
to.
is the main thing. That is the main thing. Resonance word is not bad, but resonance for a long duration is bad. I think every graph you should remember. I have shown the graph. I don't know whether you remember or not. In resonance, the amplitude gradually builds up in a conical manner. Do you still remember? I don't know. In resonance, amplitude becomes infinity, but amplitude becomes infinity after a sufficient long time, not in the first 2-3 seconds. So whenever resonance occurs, building may not fail for two reasons. One is there is damping, so the amplitude doesn't become infinitely large. Amplitude becomes large, but it doesn't become infinitely large if damping is there. Second reason is that damping is small, but amplitude could not grow to infinity because after 10-15 seconds, earthquake vanished. Amplitude was trying to reach infinity, but after 15 or 20 seconds, earthquake went away. So these are the two reasons why in earthquake, all the buildings do not get damaged. There are many reasons why. One is maybe location of natural frequency. Another one is how much damping it has. And the another one is how long the earthquake actually remained active. Some earthquake comes from 5-10 seconds. Some earthquake remains for 15-20 and maximum 40 seconds or 1 minute. So what we finally conclude that we cannot have a single criteria to decide whether the building will fail or not. We go step by step. We first try to design a building so that the natural frequency is outside. But even if the natural frequency is inside, suppose I have designed a building and I find its natural frequency is 2 hertz. Now, if the natural frequency is 2 hertz, I cannot make it 20 or 30. I have to accept that building. Then what do I do? For 2 hertz, I assume damping is 0. And this is my maximum, as per design spectrum, this is my maximum displacement. कितना है ग्राफ में बताओ maximum displacement कितना आ रहा है?
So 10 inches.
कम नहीं है. 10 inches कम नहीं है और earthquake में इतना ही होता है. 10 inches. But just because the displacement is 10 inches, I cannot straight away conclude that the building will fail. फिर हम क्या करेंगे? I'll show you. Actually, आज बहुत कुछ कवर करना है. अरे वो कहाँ गया फिगर? हाँ, this is the figure. Look at it. Now, I know maximum deformation. That is 10 inches. I know stiffness of all the column. That is K. So K into maximum deformation or displacement is called as equivalent static force. Fs. S का मतलब static. Fs. So this is Fs. Actually, it will not be a function of time. It will be a function of time t. But finally, I will take the maximum value of displacement from the design spectrum. And that maximum value will be Fs. So when that much of force is applied on the slab of the building, what will happen? That force will create a shear force at the ground level and a bending moment at the ground level. So now this concrete beam is designed against 3 things. Concrete beam is designed against shear stress design, again normal stress which comes from bending moment, and of course against buckling which comes from compressive load. Now, buckling has nothing to do with earthquake. Even if earthquake doesn't come, buckling check has to be done. So, because of this heavy mass, the force that acts on this column is compressive, and compression may lead to buckling. So that is done irrespective of earthquake. Because of earthquake, we find out the static force, and then this static force is exactly equal to the shear force, and bending moment is static force multiplied by height of the column. And then we apply our solid mechanics. If we have shear force, we know the cross section, we can find out shear stress. If we know bending moment, we can find out again normal stress. So with normal stress and shear stress, we find out principal stress. And we compare this principal stress with allowable stress. And then finally we see that this principal stress is high, but not more than tensile strength. So building will survive. In another case, this principal stress may be more than strength. Building will not survive. So please remember, earthquake does not mean building will collapse. Building will have a probability to collapse, but whether it will collapse or not, it depends on many things. Now, to discuss that, to carry it forward, let me take this example, which is fantastic example. Suppose this is a single story house. This is a single story house. In this house, the total stiffness of the column comes out to be 40 into 10 to the power 6 Newton per meter. And mass of the slab comes out to be 1000 kg. Natural frequency calculate करो, या मेरा कैलकुलेशन देखो करेक्ट है कि नहीं. Is it correct? भाई कोई मुंह नहीं खुल रहा. I mean, I'm really.
Yes, sir.
So what, as an engineer, suppose this building is in El Centro. As an engineer, what will be your comment on the building? Is it safe or unsafe?
Safe, sir.
Why?
Because,
Because
sir,
it is in a frequency zone where the maximum deformation is negligible. That is why you are calling it safe. बराबर है.
yes, sir.
Now, he is a poor man. Okay, he is a poor man. So he could construct only single story building. अब उसके बाजू में एक in the neighborhood another rich man came. ठीक है? And then his son entered into VNIT. फिर इंजीनियर बना, फिर नौकरी में लगा, सैलरी अच्छा मिलने लगा. तो then he thought that now that I am rich, single story को मैं 2 story बना देते. So that neighbor, he made an addition कि नहीं, now I am rich, I can add one more story. तो इसको डबल स्टोरी बिल्डिंग बनाते थे. So he makes this double story building. अब क्या होगा वो कहानी यहां पे दिया हुआ है, समझने का कोशिश करो. So a rich man in the same neighborhood, because he can spend money, he goes for a double story building. I mean that everybody does, not only, it happens everywhere. पैसा आ जाने से लोग सबके मन में इच्छा है हम और बड़ा मकान बनाएंगे. क्या श्राव्या, is it correct?
Yes, sir.
You are in Hyderabad?
Yes, sir.
फ्लैट की अपना घर है?
The independent house.
अरे गुड. सिंगल स्टोरी और डबल स्टोरी?
Single story.
सो यू आर सेफ.
Yes, sir.
हाँ, तो चलो अब ये डबल स्टोरी में क्या होगा बताओ. सपोज आई लीव दिस पिक्चर बिफोर यू, तुम क्या करोगे? थोड़ी देर पहले मैंने क्या बोला, जस्ट लिटिल बिफोर आई सेड दैट another poor man. I mean, I'm not saying anybody who has a single story, they are poor. I'm not saying that. But I'm saying, suppose a man is satisfied with a single story building, उसके natural frequency आते हैं 31.85, so he is safe. अब same building, another story is constructed. What will happen? Who will give me the answer in 5 minutes? I'm giving you 5 minutes. What will happen? Of course, this is not complete mathematics. You have to do little more mathematics. Anyone who has completed the mathematics? See, you should not be totally dependent on your teacher. You are going to be engineer. इतना हिंट दिया सफिशिएंट है. जिंदगी में इतना हिंट भी कहीं से नहीं मिलेगा. You have to do everything on your own. I have given you enough hint. Do the remaining part of the mathematics and tell me, sir, this will happen.
There will be two natural frequency, both one will be higher than the previous.
Again, Nitesh, कितना होगा?
Another one will be.
नहीं, कितना होगा? I have सिंगल स्टोरी का वैल्यूज हमने दिया. डबल स्टोरी करेंगे तो कितना होगा? यू एज्यूम सेकेंड स्टोरी सिमिलर टू फर्स्ट स्टोरी. कॉलम वही साइज का है, स्लैब भी वही साइज का है, विच मीन्स K1 इज इक्वल टू K2 इज इक्वल टू K, M1 इज इक्वल टू M2 इज इक्वल टू M. इतना तो खुद करना पड़ेगा. हर चीज हम क्यों बताएंगे?
19.68.
हाँ,
19.68 lower natural frequency.
correct. So this is the complete mathematics. So now it will have two natural frequency. That's not bad, but one natural frequency will become much smaller, 19 hertz. So is the building safe? Answer is no. It may not collapse. 19 hertz doesn't mean that the building will fail, but it is definitely not as safe as that single story building. So this is the problem of going into multi-story building. Multi-story buildings are very much dangerous against earthquake, let me tell you. But engineers know it, and they design multi-story building in a different manner. In India, multi-story buildings are not designed by engineers, unfortunately. They are designed by builders. तो building तो गिरेगा ही गिरेगा. Okay, so I have given you some idea about why one particular structure fails, another structure doesn't fail. There are so many things. Now, I will, this chapter, I mean, sorry, this topic, earthquake, is generally most started from 1930 or 1940, and they were the leading people. Newmark, America, he was in California. Rosenbluth, Hausner, they are the pioneer people. So if you look their papers, you will see they started first study and analysis of earthquake almost 90 years back. Those students who wants to learn this subject, there is a textbook, best textbook written by Anil K. Chopra. Now, Anil K. Chopra passed out, did his engineering from Delhi IIT during 1960s. And then he went to California. And even today, he is a professor of California, I think in Berkeley campus, University, UC, University of California, maybe Berkeley campus, may not be Davis campus. He is supposed to be, today he is supposed to be the best engineer in the area of earthquake. He has written a textbook. This textbook is available in India. ज़्यादा खर्चा नहीं है, 600-700 रुपया का होगा. This is a beautiful textbook. There you will find lot of discussion about earthquake. Now, I'm not going to, discuss deeply about earthquake because then it will take one semester. I'm giving you introduction. A few more things I have to discuss regarding earthquake. वो कहाँ पे है? हाँ, design spectrum I have explained. Okay. Now please remember that when we do the numerical integration, we do not always. एक मिनट. हाँ बोलो. उन्होंने सुबह भी डिजाइन हमें कौन हमने माना अथवा लगा Sorry, I had a phone. Anyway, so if you look at these graphs, you will see that from the earthquake acceleration, and if we carry out numerical integration, not necessary every time we find out deformation. We find out velocity also, we find out acceleration also. And this is how the graphs look different. Deformation graphs will be larger when natural time period is higher or natural frequency is smaller. See, time period large means natural frequency is smaller. But acceleration graph response will be higher for low time period and large natural frequency. So, because we can find out deformation, we can find out velocity, we can find out acceleration, a confusion comes which one I should calculate. So we have a graph. This is a single graph where all the three parameters are shown simultaneously. I'll give you the PPT and you have to study it. In 5 minutes, you cannot understand it. But these graphs, this axis is acceleration. This axis is displacement. And this axis, vertical axis, is velocity. So this is called design spectrum for all the three quantities. This is acceleration quantities, this is deformation quantity, and vertical line is velocity quantity. So engineers need this graph. Once engineers need the graph for different damping. Even if different damping is not given, from this table one can calculate. So if for zero damping, if this design spectrum is given, and if the maximum displacement for zero damping is given to me, I can find out maximum displacement for other damping following this table. So this graph and this table should be with the engineer. Then he can go ahead with his design. Now, by his design, frankly speaking, he cannot do much. He really cannot do much. He can only add damping. We are saying that natural frequency should be more than 33 Hz. ये संभव नहीं है civil structure में. So we don't try for it. If by chance natural frequency is on the higher side, we are happy. But we more or less accept that natural frequency is going to be less than 33 Hz. फिर हम डिजाइन स्पेक्ट्रम से मैक्सिमम डिफॉर्मेशन निकालते हैं, मैक्सिमम डिफॉर्मेशन से शियर स्ट्रेस एंड बेंडिंग मोमेंट निकालते हैं, एंड देन वी डू आवर टेंसाइल स्ट्रेंथ कंपैरिजन एंड वी फाइनली कम टू ए कंक्लूजन कि अर्थक्वेक में बिल्डिंग सेफ है कि नहीं है. सो दिस इज हाउ सिविल इंजीनियर्स they do design, but not in India. Not in India. India, civil engineers don't apply so much of brain, so much of thinking they don't apply. But in abroad, people do it. So, a tino PPT so today we have discussed only 3 PPT. And this is whatever I have discussed. It was, now, a jo design spectrum hai, this is, can it be used for multi-story building? We'll discuss that. Today, I only explained it for single story building. Okay. मल्टी-स्टोरी बिल्डिंग में कैसे यूज करना है वो हम डिस्कस करेंगे, बट बिफोर दैट वी शुड स्टडी मल्टी डिग्री ऑफ फ्रीडम सिस्टम, है ना. तो ये पीपीटी मैं आज भेज दे रहा. चलो आज का क्लास हो गया. एनी क्वेश्चन, एनी डाउट? फ्रॉम फ्राइडे वी विल हैव 2 more क्लासेस बिफोर एग्जाम. वी विल स्टार्ट मल्टी डिग्री ऑफ फ्रीडम. ट्रांजिएंट एक्साइटेशन एंड अर्थक्वेक खत्म हो गया. आज खत्म हो गया मतलब सिर्फ इंट्रोडक्शन दिया गया. द चैप्टर इज वास्ट चैप्टर. Any doubt, any question?
Sir, sir, for example, if a building survived a first earthquake which has a larger magnitude and there was a second earthquake in the same place, so will it survive or not?
Again, I am saying second earthquake response spectrum may be different from first earthquake.
Okay. So, but
Try to understand that earthquakes are never similar to each other. So, in design spectrum, what we do? In design spectrum, we don't look for one earthquake. we try to gather data from many earthquake and we try to guess what can be worst earthquake.
Yes,
Now,
sir.
why in India particularly earthquake is not followed in our civil design? Can anybody answer? Because the answer is very funny. But there is an answer. In India, abroad, earthquake is considered in design of civil structure. In one of the reason is of course that in India, earthquakes are not very common. Fortunately, we have earthquake, but devastating earthquake not very common. We had Latur earthquake during 90s, Bhuj earthquake 2002 or 2003 or I don't. Then Andaman Nicobar earthquake 2004. But after that, we hardly had any serious earthquake. That is one of the reason. But in future, what will happen? Nobody knows. No one can say that in future there will not be any earthquake. And in this regard, let me tell you, anybody from Pune area, Pune Satara area, any one of you?
Yes, sir. I'm from.
Uh, there is a Koina Dam. Do you know that?
Yes. Yes, sir. Yes, sir.
Now, Koina Dam, when it was proposed, many people took objection that it is close to earthquake prone area.
Yes, sir.
So people said that in case the dam fails in earthquake, failure of dam means what? Means 100 square kilometer will be flooded and people will lose their life.
Yes.
But somehow, for 10 or 15 years, there was engineering discussion that what can be. People agreed that there is a probability of earthquake near Koina. People know that. That is because of a tectonic plate is entering from Arabian Sea. You may not be knowing. But engineers studied and they came out that even if earthquake can occur in future, this will be the worst earthquake and let us design the dam based on earthquake. So Koina Dam has been designed based on earthquake. Remember that. That is the beauty. That in design, earthquake can be taken care of. Koina Dam has been designed. But generally in civil structure, particularly in building design, we don't consider earthquake in India. Kyun? Reason is very funny but simple. The moment you try to design anything for earthquake, you are making a conservative design. What is conservative design? You are over designing the things. Okay, you are putting lot of material, thinking that a worst earthquake may come, which may not come. So you create a structure which is definitely safe, but at higher cost. And in India, if it is for public to buy a building, he will never go for any building at higher cost. Dam is not for individual, dam is done by government. So government can afford that higher cost. And government should also. So nuclear power plant, it's not individual, it's government. So government goes for earthquake design in nuclear power plant, goes for earthquake design in dam, because government can spend money. But an individual, he will not go for a higher cost of a building just because it has been designed. His building is definitely safer, but he himself will not like to spend that much of money in India. Same is not the mentality abroad. Okay, and that is why in India, even if it is needed, earthquake design is not common in most of the places. और कोई question?
Sir, even if it has sustained the earthquake, but the strength of the building would be decreasing, right?
No. Strength of the building will decrease if there is some crack and other things. It occurs. If the crack doesn't occur, see, within the elastic limit, you know that within the tensile strength, the deformation is recovered 100%. That is why we call it tensile strength, because stress strain graph is elastic. Once the earthquake has gone out, the deformation is zero again for elastic. But suppose some damage takes place, तो उस समय वो खड़ा है, फ्यूचर में डेफिनेटली इसलिए आफ्टर एवरी अर्थक्वेक a building should be checked, no doubt about it.
Sir, the limit of 33 hertz maximum frequency.
No,
is
let me
declared
tell you,
by the-
fatigue has no meaning in earthquake.
No, sir, no, sir. Actually, I have another doubt.
bolo.
You said, right, if there is a possibility if we can have a natural frequency greater than 33 hertz, then there is a less possibility of getting effect or the
Okay.
whatever the design which has a more
Correct.
natural frequency will be a safer design. But sir, like this is whatever the observations have made till today, or the earthquake which are generating or the pattern of earthquake, on that basis this is the conclusion, or this is the assumption,
Correct.
right, sir? So will it be means not of if unfortunately any earthquake comes which is has more than
No,
33,
that's what I'm
then-
saying. No. Let me tell you
Yes, sir.
one thing. Anything about earthquake is probabilistic. I think I have used this word.
Yes, sir. Yes, sir. Yes, sir.
No design is 100% safe.
Yes, sir.
Any design, anything we talk about earthquake, it is probabilistic because it is future.
Yes, sir. Yes, sir.
Generally 33 hertz आज तक एक भी earthquake exceed नहीं किया anywhere in the world. But it doesn't mean that it cannot exceed. But the probability may be 1 in a million.
Yes, sir. Yes, sir.
That is the thing. So it is a probabilistic statement. But if somebody asks what is the probability that an earthquake will have 25 hours, I'll say probability is high. Maybe 50 times out of 100. So that is
Yes.
the thing. Probabilistic approach.
Okay. Okay, sir. Thank you, sir.
और कोई
Sir, I have a doubt, but not regarding the subject. Sir, after 21st, college is reopening, right? So how are you going to teach? Is it hybrid or completely
no, let me
offline?
I will let me tell you, if institute is allowing you to come to the campus, I will take only classroom class. I cannot go for hybrid. Simple. I cannot go for hybrid because I am not in that much expert. It has to be classroom teaching. And that is not the reason. The second reason is that classroom teaching cannot be replaced by this online teaching. Online teaching is bad. You should try to accept it that online teaching is bad or online learning. So the moment you are given an option, you should take the better option. So this is my statement. I'm not saying other teachers may say that they will continue online. That is different. But mine is the moment I get an opportunity, I'll go for classroom teaching. Simple. Classroom teaching is far better than online teaching. See, I cannot write down anything on the board if any idea comes to my mind immediately. I'm teaching this subject for last 25 years. I'm extremely depressed or discouraged now, the way I'm teaching it in online. So if institute allows, the day institute will allow, I will go for classroom teaching. For all the student, you prepare yourself accordingly. नहीं तो इलेक्टिव छोड़ दो, अभी भी संभव है तो इलेक्टिव से निकल जाओ, ठीक है? क्यों श्रद्धा ये सवाल क्यों हुआ? Why you are asking this question? You don't want to leave Hyderabad?
No, sir, I want to come to college, so we can prepare the date at which time we have to.
No. I think there should not be any doubt in this regard.
Yes, sir. So,
For a long time, all the students have been out of campus.
yes, sir.
How long you will continue to remain out of campus?
So we were
So,
asked to come by 21st March, so we'll be coming by 21st, 22nd. So depending on that,
No.
wanted to come
मैं
from.
तो उल्टा बोलता हूँ. Why you should arrive on 21st? Institute will allow you to come before also, 2-3 days before. See, the notice that has come up yesterday is a horrible notice. That notice doesn't talk about what will happen between 11th of March to 21st March.
Yes, sir.
So you can imagine what kind of people are handling administration of the college now. Actually, immediately after your mid-semester exam, we cannot stop teaching. Teaching will continue. In the same notice, they have also said online teaching is up to 28th of February. They should have said for third year, online teaching will be up to 20th of March. They should have said. That is a mistake in the notice. And from 21st, students should report to the campus and teaching will be hybrid. So institute is saying teaching will be hybrid.
But
As
sir,
far as I am concerned, no, let me finish. As
sir,
far
they
as I
have-
am concerned,
Okay.
I cannot handle hybrid kind of teaching, so I will go for classroom teaching. हाँ बोलो अभी.
सर वो आने जाने के लिए भी कुछ लोग दूर है तो उनको टाइम लगेगा. सो ऑन दैट
अरे,
बेसिस 21 उसके बीच में
Let me
एक
tell you,
slot भी तो
let me tell you,
clear किया.
ये सब बातें उसी
Yes, sir.
समय करना जब नौकरी में ज्वाइन करना होगा. If Google ask you to join today, will you
Yes, sir.
reply this way to Google कि मुझे आने जाने में 20 दिन लगेंगे?
नहीं सर 20 दिन की बात नहीं कर रहा. लाइक
Then-
आई एम कंक्लूडिंग दैट
No,
11 to 20
all these things do not arise. I mean, don't talk to me like this. Don't talk to me like this. These are the kind of mentality with which you are going to be engineer. You can talk to other teachers. Don't talk to me. College has given sufficient time. 21st March is almost 1 month from now. I can understand some unforeseen phenomena. Train line disrupted, trains not running, that I can understand. But you are already thinking not sufficient time, all these things. तो ठीक है, मैं कुछ बोल. But as far as I am concerned, अगर 26 स्टूडेंट में 20 स्टूडेंट भी क्लासरूम में आ जाता है, बाकी 6 स्टूडेंट्स को मैं अलग से ऑनलाइन नहीं पढ़ाऊंगा. दैट इज व्हाट आई एम ट्राइंग टू से. That is what I'm trying to say. The remaining 6 students cannot come with an excuse. Sir, मैं आ नहीं पाया, मेरे बुखार हुआ. 20 बच्चे आ गए कैंपस में. So it is up to you. How much serious you are. I can understand individual cases. किसी का घर में कुछ हो गया, वो 1 हफ्ता नहीं आ पाया. I can understand that. But don't try to dig out problems. I'm talking only about this subject. I'm not trying to generalize for other subject. Other subject क्या होगा और respective teacher दें. As far as I am concerned, if institute is allowing you to come to the campus, please come to the campus so that we can restart our classroom teaching. That is what I'm trying to say. Classroom teaching is far better than online teaching. You have to accept it. So don't run away from it. If anything happens to an individual, that is separate. और कुछ? चलो ठीक है.
Yes, sir.
हाँ हाँ
I have a doubt, sir, regarding earthquakes.
हाँ बोलो.
Sir, generally, if one earthquake comes, it follows with an aftershock, no, sir?
After?
Aftershock.
No. An earthquake comes back. Aftershock it doesn't come every time, but sometimes it comes little later. Agree? I agree that. But by that time, my original vibration has died out.
Yeah.
Uh,
So there
so-
will be sufficient time gap between those two earthquakes.
नहीं सी 10 सेकंड भी मिल गया तो इट इज सफिशियंट. कभी कभी क्या होता 2-3 मिनट के बाद इट रिविजिट्स अगेन. It happens. At many places, earthquake has come back again after 2-3 minutes. I am saying 10 seconds is sufficient. है ना?
Okay, sir.
ठीक है. चलो, I am leaving now, huh?